Cool. Matthew is another one of the Dun.js core team members. He released he released a pretty awesome project last week. Matthew, do you want to share your screen? And
yes, I do.
Yep.
Okay. Yeah. Well, first, VelociRender is a really cool thing. I think it's my opinion. I'm entitled to it. It's a really cool thing that allows you to like speed up websites, single page app websites. But first, Bitovi /VelociRender on GitHub. There's a link in the show notes. Go there, hit this star button. It's right here. See my mouse? Hit star. It's funny because I can actually click here and I can see a list of everyone who started, and I can compare that to everyone that's at this meeting right now.
Matthew,
if you're not on this list,
hit star. Should I hit star again?
no, just one time.
Just once. Okay.
Like I said, if you don't do it, that's fine. I'll remind you later. I promise. Just kidding. Maybe we'll see. Okay, let's get to the meat of this. VelociRender is a fun project that helps speed up single-page applications. It is a web server. Yeah, let's get to this slide. What is it? It's a web server, right? It's a web server it's a CLI tool, command line tool. You run a command, you give it an HTML file, it starts a web server, and it serves that page, but it does some other stuff, and it like speeds it up. It's focused on page load performance. So I have a few slides and I have a very short demo, and I'm gonna try to speed through all of this. But yeah, what is it? It's a web server. What is it not? Well, it's not an alternative to using server-side rendering for SEO purposes. If SEO is your thing and that's the entire reason for like using some type of specialized web server, this might not be exactly what you want. It's not a competitor to other SSR frameworks like Next.js or Angular Universal or Dun.js. These are more like full frameworks. They provide, generators for bootstrapping an application and that kind of thing. VelociRender is not that. It assumes you've already created an application. This is like after you're already ready to deploy. Okay, let's talk about the different ways that there are to render spas. We're going to go through it. You can debate. I think there was a recent article about different ways to serve your single page application, and it went through maybe 5 or 6 different ways. These are 3 of the most common ways. Well, these are 2 of the most common ways, plus VelociRender. So let's go through those. Server-side rendering is a first. And what server-side rendering is, it's a way to take your application code, run it on a web server, on a Node.js server, run it similar to how you run it in the client, and generate a full string of HTML, like the entire page, everything the user ever wanted to see. If JavaScript was turned off, they would see basically the same thing that they would see when it's turned on. It just wouldn't be interactive. So that's what server-side rendering is. Client only, when I say client only, I refer to all rendering actually happens in the client. You just send kind of a shell of HTML. If you see here, it's got like the head stuff, but then it just has a body. And there's usually like a root element, and your JavaScript is going to run, and it's going to attach itself to that root element. And
Matthew, if you're showing other slides than the intro slide, I'm only seeing faster load times for any framework. There we go.
Now, if I switch now, did it change?
Yeah, it just updated, yes.
Okay, well, that's fun. Anyways, yeah, there's 3 of them. Hey, we're here now. Incremental, okay. So you know what client-side rendering is? Incremental rendering is kind of like, in terms of what it produces, is sort of in the middle.
Sorry to interrupt you again. If you're on an incremental slide, we're still
okay,
there.
I'm just going to stay here. I'm just going to do it this way.
I had to go now. Sorry.
That's all right. Incremental rendering is kind of like server-side rendering, where it does take your application code and it does run it on a server. However, unlike server-side rendering, it doesn't wait for like all the dynamic stuff to happen. Like, for example, database requests. It doesn't wait for any of that at all. It just kind of it gets you kind of the skeleton of your website, kind of the header, the footer, that kind of thing. But all the parts in the middle, all the dynamic parts that require database requests, those come later. And it does this by kind of like bootstrapping. It does this by rendering on the server and then like sending these mutations to the client. I'll get to that here in a second. Let me skip past that part. Let's talk about some of the pros and the cons of these 2 different approaches. With SSR, the biggest pro is SEO. If you want to reach search engines the best way possible, that's the best way there. There's also perceived performance, especially if your database requests are fairly fast, as long as they're not that slow. The user is going to see content immediately, even though the application is not actually running yet, and that allows them to like see content. The cons is that you do have to wait on all your DB requests or any other API requests. Like, for example, if you were hitting the external API like Stripe or something, you have to wait for all that stuff to happen before you can send the user anything. And because you're waiting for that, that also means that there's a delay between the time that it delays until the browser can start downloading JavaScript and CSS. You know what I mean? Like, we have to do all this stuff on the server, and then the browser can start like actually booting up the application. So that's kind of the downside. For client-side rendering, the biggest pro is that we get to start the request sooner because you get the HTML to them immediately, and then the application can start downloading, start fetching everything. And for me, the biggest pro for client-side rendering is the ease of deployment. Like, literally, it's just static content. You still want to have an API server, but for the front-end part, you can like just serve that straight up from the CDN. It makes it very easy. Biggest con is that there is no initial content. So if you have a poor connection, especially with one with bad latency, latency refers to the time it takes to like make a round trip from the server to the user's computer. If there's a lot of latency, there's this time where you have to wait, you have to make a request, and you get HTML, and then you have to make a request for CSS, and you get that, and then you have to make a request for JavaScript, and then once the JavaScript executes, you make a request for data. So it's kind of like this compounding effect that happens. Incremental rendering, the biggest pro is, well, it's similar to client, is that we get to start everything sooner, but we also get to start rendering dynamic content sooner, and we do that because, like I said, there's this mutation stream going on that I'll show you about, and that makes it like the fastest that you can get to interactivity because you're getting dynamic content while the application is still booting. Biggest con is that the SEO is not, it's not really built for that. And I guess the other con would be that it's even better with H2. Like, it's still better with H1 than it's still faster, I should say, with H1. But it's even better with H2 because with H2 you can even do more stuff. You can like get stuff to the client sooner. And H2 is not super widely deployed. Okay, so about how it works. There's this read the article because all the stuff I'm talking about is in the article. This pretty diagram. The browser makes a request to a server.
Your slide didn't update again.
Down here. And then the server starts, especially if you have an H2 connection, it's going to push HTML, JS, commands, styles, all that stuff at the same time. And then the server is going to start sending commands. And these commands are like mutations. They're like, insert this, change this text over to this other thing, and that sort of thing. So that's how it works. The best way to think about it, if you find it confusing, and sometimes I do, is that it's basically it's a head start. You know what I mean? Like, it's like we know what you're going to do once you get to the client, so we're just going to go ahead and do that same thing on the server, give it a little bit of a head start, and we're going to send it to you kind of while you're waiting on everything. It's kind of like when you go to the dentist and they have the magazines out for you to read while you're waiting for your appointment. VelociRender is the magazines, I guess? I don't know. Maybe that was a bad analogy. Probably thought about that before.
It'd be like if they handed you a toothbrush or something while you're waiting at the.
Oh, yeah. That's good. That's perfect. Okay. All right, let's do a quick demo. Okay. So VelociRender, like I said, it is if I go no modules, bin/VelociRender. It's a web server.
We can just see Chrome right now, FYI.
Oh,
we can't see your terminal.
I'm really bad about sharing, Ernie. Should get better at sharing things.
There we
okay.
go.
So, yeah, here's the CLI. I'm gonna use a super secret environment variable called doneSSR debug, and that's going to enable some debugging output that's useful for demonstrating what's going on. This is also being throttled to kind of simulate a poor connection, maybe like a slow 3G connection. And we can just kind of see what's going on. Let's first look at the network tab. As you see, everything loaded pretty quickly. If we look at our network tab, we can see we got initial chunk of HTML, and that's going to attach a few things. It attaches this JavaScript, and it attaches some CSS, and there's a mutation string here. So what's interesting here is you can see the time between when JavaScript actually starts to execute. It took until 1.5 seconds for it to start executing, if I'm reading that right. Or no, that's when it started downloading. I'm sorry. That's when it started downloading. It had to wait for the page to load before it could start downloading the JavaScript. And I have some stuff in my way. It took until about it took another 1.2 seconds before it could start, before I think the full download was complete. And that's before it started executing that particular JavaScript. Then we have this other thing, this mutation stream. So again, this is kind of preloaded by the browser up front, and then there's a script that attaches to this, and actually that's what, when you see the effect of these items updating, that's coming from this mutation stream. And this is just a stream of command that says, you know, attach this lead, change this, whatever. And we can see that that started, this time it started at about, it's going to start at about the same time the JavaScript starts. However, unlike the JavaScript, it doesn't, you don't have to wait for this thing to download. It's a stream. And there's a small script attached to that, to the page that starts retrieving the stream and actually attaching all these different things. If we scroll down, we can see the API requests. That's because the actual application is making API requests in the background. And move some stuff around. We can see that it wasn't until 2 seconds into the process that we started. That means this is how long it took for the JavaScript to execute, more or less. And so there's a gap there, right? Is that the mutation stream started at, it started at 710 milliseconds, and the data request started at 2 seconds. So it was like a second and 1.3 seconds where we're actually mutating the DOM, we're actually showing the user dynamic content, but the JavaScript actually hasn't started fetching anything yet. So that's kind of a nice thing. The debug content, let me show you that quickly. Like I said, if you use this flag, it's done as our debug, it will show this, it will show the mutations. Let me do it a couple times. Yeah, I like this one better. So what's another cool property of VelociRender is that streaming is kind of out of order. And what I mean by that is that this LI, this mutation here, happens first, and then we get another mutation, which is 15, and that's the card count. And then we get more streaming LIs come in one after another. So that's kind of nice, because traditional HTML streaming, which is not something I talked about, it does top-down streaming, which means that we have to wait for the cart to update before we can start updating these list items. But with incremental rendering, we don't have to wait on that. I guess that's all I have. Incremental rendering is pretty cool. Go start on GitHub. VelociRender enables it. I wish we had more time, but I'll talk to everybody after, and that'd be fun.
It's awesome. Thank you, Matthew.